All right, good morning everyone, and thanks for joining this track, this first session. Well, what I want to present you today is my personal initiative that I'm doing in the last few years. So you can possibly consider that as a kind of update about the status, but actually this update this year was supposed to be coming with some real results in the form of demos. Well, unfortunately, I just learned before this session that I will have to present not from my laptop, but from this standard laptop, because we do live video streaming, which is actually great. But because of that, I will have to skip my presentation part, unfortunately, as a part of this talk. But I possibly will be able to answer a few more questions, or just maybe give a few more comments about some specific things. And then for the audience in this room or just at this conference, I certainly will be more than glad to show those things that I will be talking about in real during today and the next 2 days. Well, with that being said, let's just move forward. So first of all, I possibly will be playing Captain Obvious with this slide, but certainly when we as engineers, as technicians in the telecom industry, doing our jobs, developing software, testing software in the field, in the lab, we definitely need oftentimes to deal with the signaling messaging, debugging and tracing, and for that we're using the tools that we have. Well, on that tooling side, we certainly have some very good and very well-known instruments in our hands, Wireshark being a great example that I think everyone in this audience knows. But in the recent years, actually for quite a few years already, we started to see a number of challenges in using those traditional older tools. And I just tried to summarize a few of those most prominent that I myself observed and that I know my colleagues were struggling with. So in particular, these days, definitely most of the communication channels, possibly all of them, are encrypted. And that's a real need that must be done. But unfortunately, that comes with a specific price when we consider debugging, because debugging and encryption in some ways go just against each other. And then with the modern technologies like WebRTC, we have to debug different types of applications these days. And not only traditional telephony, but also those ones in browsers or the ones on the mobile devices, which is our main topic for this track. And besides, we oftentimes see a combination of protocols in the modern telecom solutions. So different types of protocols, be it traditional ones like SIP, be it some custom ones based on JSON, interacting with each other. And again, developers need to somehow be able to handle that complexity. Well, on this diagram, I tried to depict several general approaches to how we can collect dumps and traces from the practical perspective. So not much of the commentary that I possibly have to do here, but just real brief, definitely on those stack, IP stack layers that all of you know really well. We typically either go really low, just right above the physical layer with the tools like Wireshark and many others of that sort. And we just try to collect pretty much everything. So we go pretty much like a vacuum cleaner, collecting all the packets that flow in that particular system. And that certainly is great because then we have the exact picture of what was going on. But again, if you deal with encrypted channels, then it becomes a challenge because at that point we can only collect the encrypted traffic. And either we just cannot do anything about it, so we cannot really check the contents of it, or we have to go for some extra complexities to actually get the keys from the systems that communicate to each other, and then use those keys later to decrypt that collected traffic. That may be working in the lab. Well, that still creates quite a few challenges for developers, but it may be working. But when we come to the field debugging issues, that stops working. Well, the other approach, quite on the opposite side, we can actually log the messages and collect some traces at the application level, potentially. And that may be working really great, because in this specific talk and from the real perspective, typically we care about the application level signaling anyway. SIP and all those JSON-based variants, or REST-based, or XMPP, all of those are just application signaling. We really don't care about all the transportation and networking and other layers down the stack. However, the problem at that point is that either people go with some custom protocols. There is no real standard for that at this point of time. Or there are some attempts to standardize that I know of. But those actually are all aimed at specific protocols. They are not universal at all. So with that being said, let's just quickly go through some drawbacks. So again, I mentioned that first option with the system level dump collection. So first of all, we typically, when we deal with encrypted channels, we somehow have to do key login, or we have to disable the encryption. Both of those options are not great, especially if you have some backdoor to disable the encryption in your system. That may be a threat for the real applications, and then for the real scenarios, you just cannot typically disable it at all, or certainly it wouldn't be advisable to do so. And then dealing with the low-level packets, we actually have to go through much more complexities. If you use Wireshark, then certainly Wireshark will do all the job for you, decrypting and reassembling all the chunks from the bottom layers of the IP stack back to the original packets that you use. But what if you want to use Wireshark traces with some third-party apps? And I can tell you that I tried it a few years ago, maybe about 6 years ago, and I was surprised at how many problems third-party libraries that claimed to be able to read those Wireshark traces, how many problems they actually had trying to go through all those lower layers of the stack to actually recreate the original packets. Most of them just crashed or stopped or couldn't handle most of those dumps, aside from a few ones. So, I mean, that was a challenge as well. And then the last thing that I wanted to mention here is we kind of got used to that for our practice. But the fact is that for many years we had the traces collected with tools like Wireshark and the actual application logs being separate. And while it can be working in practice, it will be much more convenient to actually have those things together in just one bundle, ideally. So I wanted an alternative option to that. And so I wanted pretty much just to address all those points. I wanted to be able to dump both the signaling and the actual logs. I wanted to add some meta information to that, some extra details. And I wanted that to be easy to be extendable, extensible, and unified and interoperable. So I wanted to try to create something that I could propose to other people as a common standard, hopefully. That's what I'm working on. So, I checked existing options. I actually checked many of them. I didn't find what I was looking for. So that's how I started what I wanted to talk to you about today. So what I'm presenting here, the protocol and the format behind it, I call it SALSA. SALSA stands for Simple Application Log and Signaling Archive. Easy to remember. So first of all, with SALSA, I want to do things that basically many other login applications and login formats were trying to do. I want to actually capture events. So that itself is not something new. But the fact is that, again, I wanted to do that for both types of messages, if you will. So I wanted to be able to capture the actual messages exchanged between the modules, hosts, applications, components in the system, where we have a source and the destination, and message conveys some meaning, some information between those two peers. But then you will be able to capture that and put the exact dump of that in the log for later examination. And at the very same time, we also have the more traditional application log messages, where the messages themselves are intended to be just going to the log, not to somewhere else. And they are intended to actually capture the state or some events happening inside the system. And typically that would be in a human readable form, something that would be more understandable for people for later inspection of those things. So I wanted both of those different categories to be just a part of the same thing. And looking at different attempts that were done around that in the past, again, that was just all about the custom formats, no compatibility here. But people either ended up wrapping the dumps inside the signaling messages, so creating one extra layer of indirection, or just going the other way around, so wrapping the actual logs inside those things. I wanted both of those to be at the same level, first citizens, if possible. So with that being said, with SALSA, SALSA consists of records, again, not something very new in itself, possibly. And it does both message and login event capture, as I mentioned to you. And it allows, with each message, to pass not only the dump of the message, and the dump can be in the binary format or can be in the UTF-8 textual format, so any kind of data that you want. You can also associate extra details with that. What's the source, what's the destination, what's the protocol. And this is great because when you log those details at the application level, it actually is something that application typically knows anyway. So unlike the Wireshark that actually has to reconstruct the initial packets and figure out what specific protocols and formats were used in each specific case. In this case, we actually can give a great help to the applications that will be examining the logs later, because at the application level, application knows what protocols it's using. So it can just share the information right away. Well, we still can consider some cases where that information may not be available. So later some extra check-in or try and error can be done. But again, in most cases, we can just add that information right away when we log the things, saving much time later, and actually that helps greatly when dealing with some custom formats of protocols, because with custom formats, Wireshark cannot help you unless you create your own dissector for Wireshark. In this case, you can just do all the annotations right away. Well, with that being said, that's about the messaging part. So again, the things that fly in between the peers in the system conveying some meanings. What about the login side that I was talking about just before that? Well, on this side, SALSA offers an extra mechanism. And that mechanism is called data reporting in SALSA streams, or DRESS in short. So the DRESS protocols are a part of SALSA, and they are just a simple, basic protocols or extensions to SALSA, if you will, that people can create to convey specific data, specific reports with specific parameters in them, whatever they want. Pretty much. And, well, each of those DRESS protocols have their own unique ID. The format is designed in a way that the names of those protocols cannot clash with the names of the standard protocols, like SIP or XMPP or whatever. So they will never clash with each other. Again, I will go into some more details later. But with that kind of thing, DRESS protocols, we can essentially dress the data for specific reporting, if you will. So one of the DRESS protocols that is defined just right out of the box in SALSA is the one called log. And it's just a very simple extension that includes the messaging in a free format with some extra data, the log level, pretty much like the syslog that you know of. And also, when I was working on that, many colleagues actually asked me to add something that would allow to set priorities within the log level to indicate that. So I introduced an extra parameter called rank. And so that way, with this specific DRESS protocol, we can address the login needs as easy as we can do that with dumping the packets. Well, I mentioned that SALSA captures events, two different types or categories of events. But I also wanted something more from my practical needs and perspective. I wanted to be able to add some extra details to the logs, like maybe we have some information about the IP addresses that the system has. Maybe we want to add some information like aliases or public names to specific components so people can have more information about that. Maybe we want to share geolocation of specific components where we capture packets. Maybe we want to add some comments to them. Actually, there may be different ways in terms of what types of extra information or details we may be willing to add to our logs describing specific parts of the picture. So from that perspective, SALSA includes an extra mechanism to address that as well. So it deals with entities, and entities can have extra details associated with them. And right now, SALSA includes just some very high-level basic entities. It's a component which can be pretty much any peer in your system that may be something as big as a cluster of computers. And it can be just a separate host, it can be an application on that host, a service on that host, a module inside the application, a library, a specific function, whatever level of granularity you want to achieve with that from the practical perspective. Then the protocol itself. The protocol is an important part here because, especially with the custom protocols, we need to have a way to add some extra information about it, what it's like, what the format of that custom protocol is, so we can deal with that. And finally, I included an extra entity which is called a scope. And the scope is generally just a message or a combination of messages, which can be associated together in whatever criteria we want to have for that. So it's very flexible. And then in terms of details that we can add to those, again, just a few examples here. There can be much more, but something like IP parameters of a component, or a public ID, which can pretty much go with a component or a protocol or a scope or whatever we need, or a format clue that's applicable to protocols in this case, suggesting what a specific protocol looks like. Some more generic things like, like CPT, for instance, is just a variation of SIP, and then XMPP is a variation of XML. So we can just go, from some more specialized ones to more generic ones, and then with that kind of clue, system that handles that log, even if it doesn't know the specific custom protocol, it can possibly just figure out and be able to still decrypt or colorize the logs for better readability, or do some other things just based on some more generic information about the protocol. Again, what it's like, what it looks like. Well, so that specific aspect is addressed with another address protocol in SALSA, and it's called node, not surprisingly. So it allows to link any details to any entity and do that in a retroactive way, which means that you can add some details just as you go with the logs in real time if required, but you can also add those details later. So stuff like commentary or discussions about things, or maybe just some markups in terms of identifying the scopes inside the logs, that can be done later when the actual session capturing the packets is already over. So it's very flexible. And then again, it's mainly, this part is mainly aimed at just reporting some fixed parameters that do not change very often, so not the real events during the sessions, but something more fixed. But it still can deal with some types of events, because if you think about something like a commentary on top of the existing log, where developers just discuss some specific things, that's also a kind of stream of events, but that is a very separate stream of events, maybe happening just very much later in time compared to when the log itself was collected. So those kinds of things can be actually handled with this mechanism, the REST protocol called nodes. Well, now just real quick about the format of the SALSA, what it looks like. I tend to call it a hybrid format. So from the very high level perspective, it's a binary format because it's able to send some binary data in it. It's a binary format, of course. But in reality, SALSA is designed in a way that allows applications to either use both the textual and binary part of it, or just textual part of it. And that adds a great amount of flexibility, because for the low-level applications, for the applications done in native languages that certainly can very efficiently manipulate bits and bytes, they can just do the dumping of the binary packets as quick as they can, as efficiently as they can with SALSA. At the very same time, if you go back to some scripting languages and applications, be it JavaScript or Python or whatever else we need, Lua maybe, some of those languages already have tools and mechanisms to work with binary data these days. But still, in most cases, that's kind of rudimentary, and some languages have problems working with those data. So they can leverage only the textual part of the SALSA in that case. They are not required to go into the binary data at all, because at their level, if they are not able to work with the binary data, they're likely working with messages in the text format anyways. So they can just log those as text, and all the markup around that is done in text as well. That adds a great flexibility. And then speaking about the format itself, for the binary data, it includes the first section of the record, which is an optional one, and that is just a dump, and the length of the dump prefixed to it, and it goes in a textual format. And then after that, we have a text section, which essentially just closes the specific record, and that one is in JSON. And that JSON format itself, it's very simple. It's just a few fields, actually. So, well, here at this point of time, I wanted to give you a quick demo, and we could take a look at some real files in SALSA format. Well, again, for those of you in this audience, I can show you that later. Just real quick about some perspectives for SALSA that I see myself and that I aim at with this format. So, like I mentioned, with SALSA we can hopefully annotate and inspect logs and messages that applications exchange, visualize those. Most of my colleagues, when I mention this initiative to them, say, the first thing that we need to be able to build a flow diagram. And again, if I had some more time, possibly after this session, I can just show you the real flow diagram built with SALSA, for an example. A little bit more advanced things that possibly are not quite here yet, but I think the potential for them to come is all here with the SALSA features. Automating analysis and collecting some stats around the logs, and eventually replaying the scenarios for traffic testing and debugging purposes. What can be the sources where we can grab SALSA from? Well, certainly I hope I already created a few demo libraries for clients, but for different languages, different platforms and frameworks, I certainly hope that as this initiative is taking off, people will be able to create libraries to support that in different programming languages and different tools. That's one part. The other part is about the web applications and web browsers. Again, the applications can do that themselves, but it might be very great if we had for browsers some plugins or extensions that do the thing, and that's very possible because with the plugins and extensions they have access to much more information that the application typically has. So we might be able to capture some more details and protocols that at application level may not be visible at all. So application may be using some of those protocols, but maybe not able to actually see the real packets and details about those, while plugins and extensions may have access to that inside the browsers. And then eventually, hopefully, in the browsers, we may have support for this format as well natively. That will be the best option, but possibly will take more time. And then certainly converting from other formats and protocols. I have a ready demo of a converter for Wireshark. Well, you may be wondering why we need to convert from Wireshark with all these things that I described. Again, the synergy here is that you may be able to collect something with Wireshark. Again, I'm not trying to dismiss this tool. It's great for what it does for us. But for the scenarios where you have some places collected in Wireshark and then some traces and logs collected at the application level, you may be able to convert from Wireshark to SALSA and then just merge those things together. And that may be very helpful. Well, at this point, I plan to give you a second demo with a real web app, just a simple demo app, but enhanced to support SALSA. So again, possibly after this session, I will be able to show that to you if you're interested. And then just to wrap up, several things. Applications, if they need to support SALSA, they can go two ways. They can either embed the functionality to produce the SALSA logs formats themselves, or they can just use some third-party libraries, in which case what applications themselves need to do, they need to be able to have some hooks inside them or some places inside them where they first log the information. They naturally have that already in most cases. And second, some calls need to be added to actually support dumping the packets. Sometimes it's done already with the logs, but again, missing many of the features that I described you. So those places would need to actually include calls to specific SALSA libraries to dump the packets. So either go in SALSA native or SALSA friendly, as I call it. And then SALSA is aimed to be streamable. So you can just put the SALSA streams in files, or you can just transmit them in real time to some remote hosts, which in specific scenarios may be very viable. And then finally, we definitely need tools to be able to play with SALSA. So I just created a demo tool that I wanted to show to you. It's called SALSA Deep, and it's a web-based tool running all in browser that is able to read SALSA files and do some search in them and do some filtering and again building flow diagrams. So something that people can real quick try and see what this format can do for them. Well, with that in mind, let me wrap up. You will find my addresses and social network accounts in this presentation. And I don't know, we have about a minute for questions, I guess. Any questions or feedback?
Are any of these available as samples that we could click on and download?
Yeah, well, some sample files with SALSA are at my GitHub. The specs for the formats will be available here possibly in a matter of days. I just, like last minute additions that I was doing to that with all the recent things that I added. So those all will be published. And then the library that I mentioned for JavaScript and the library for Lua and the tool for Wireshark that I mentioned to you will be published. And then the other part, the consumer part, the browser-based application that allows you to play with those. I also plan to release it at GitHub so people can play with that, and hopefully that will help the whole initiative take off. That's my intention.
Okay. Thank you very much, Vlad.
All right. Thank you so much.